All right, let's go over the chemistry exam review. So, first one, you were supposed to find the number of moles given a certain number of molecules. So you're going to use 6.02 times 10 to the 23rd over 1 mole. Okay, equals, I'm going to bring this up here to save myself from turning around, 4.2 times 10 to the 23rd. That's molecules of MgSO4. And we're trying to find X moles of MgSO4. So from there, cross multiply. So you go with 6.02 times 10 to the 23rd times X equals the other direction, 1 times 4.2 times 10 to the 23rd. So we gotta get X by itself, 6.02 times 10 to the 23rd on both sides. And if you type that into the calculator, remember that you're not going to type in times 10, you're going to type exponent or double EE, depending upon which kind of calculator or the calculator on the computer you're using. So the answer to this one, X equals, when you round it off, 0.700, and that's moles of MgSO4. This is what you should have for number 1. All right, number 2. Number 2 is talking about volume. So because it's talking about volume, we've got to use the 22.4. So there's 22.4 liters per 1 mole of any gas. So it doesn't even matter which gas it is. But then we're trying to find out X liters of nitrogen, given that we have 5.38 moles of nitrogen gas. So from there, cross multiply X times 1. Equals 22.4 times 5.38. If you multiply that out, X is going to end up equaling 120.5. That's liters of nitrogen gas, is what you should do for that one. So that was number 2. All right, on to number 3. Number 3. Again, they're asking for how many given a certain number of moles. So we've got to use 6.02 times 10 to the 23rd is 1 mole. And we want to find out X molecules of calcium carbonate, given that we have 7.34 moles of calcium carbonate. So from there, cross multiply X times 1. Equals the other way, 6.02 times 10 to the 23rd times the 7.34. If you multiply that out, X ends up equaling 4.42 times 10 to the 24th, and that's molecules of calcium carbonate. Would be the answer for number 3. All right, on to the next one, number 4. Number 4, you got to find the molar mass of some elements and compounds. So first one is calcium. Well, it's just the element calcium. There's no number for it. So it's just one of him times his mass, which is 40. So that's 40 grams of calcium per 1 mole of calcium. So that's the first one. Second one, you got NH4, 2, and CO3. So it's ammonium carbonate. So for this one, in the brackets here, we got 1 nitrogen times his mass is 14. Plus we got 4 hydrogens times its mass is 1. All of that times the big 2 out in front, or the 2 that's right there. Now we're going to add that to, we got 1 carbon times 12, plus we got 3 oxygens times 16. So if we multiply this stuff out, we got what? 14 plus 4, so that's 18 times 2, so that's 36 plus 12. Plus 48. Yep. So we're going to turn out to be 96 grams of NH4, 2 CO3 per 1 mole of it. Okay. And let's go to the third one. I'll turn it just a little bit. Third one is HNO3. So in this one, we got 1 hydrogen times 1 plus 1 nitrogen times 14. Plus 3 oxygens times 16. So that's 1 plus 14 plus 48. So that is 63 grams of HNO3 is what you should have for that one. So that's number 4. All right, on to number 5. Let me erase all this stuff. All right, number 5. Number 5, we are supposed to find, given we have 328 grams of something, how many moles? So the substance we're talking about is copper nitrate. So it's that stuff. So the first thing we got to do is we got to find out its molar mass. So we got to go, there's 1 copper times his mass is 64, plus we've got 1 nitrogen times 14, plus 3 oxygens times 16. All of that times the 2. So that's 64 plus 2 times, let's see, it's 14 plus 48. So that is 62. So that's what, 124. Right, yep. Plus the 64. So that turns out to be 188 grams of copper nitrate. Oops. I didn't do that right, sorry. Copper nitrate per, there's no number out in front of it, so that's per 1 mole of copper nitrate. I'm going to go to the other side and go, well, I don't have 188 grams, I've got 328 grams of copper nitrate. And we want to find out X moles that is. So from there, cross multiply. So you have 188 times X equals 328 times 1. So divide both sides by the 188. And X ends up equaling, still on my screen, yep, 1.74. And that was moles of copper nitrate. And remember, when you do these, make sure that you give the moles and you give what substance it is to get full credit for your units. All right, that concludes number 5. All right, number 6, percent composition of calcium carbonate. So we got this guy. We're going to do the percent composition of each of the elements. So we got to do his molar mass, so that's 1 times 40 for calcium, plus 1 times 12 for the carbon, plus 3 times 16 for the oxygen. So we get 40 plus 12 plus 48. So that's what, 60? That's 100. Oh, this one was the one that was too easy, because the total mass is 100. So now what I have to do is take each one of these and go, well, for the calcium, it's 40 divided by the total mass of 100 times 100%. So that works out to be 40% of its mass is calcium. And then we got the carbon. It supplies 12 out of the 100 times 100% equals 12% of its mass. And then we do the oxygen. He supplies 48 out of the 100 times 100%. So that's 48% of the total mass. Okay? So that's how you get percent composition of this. All right, number 7. Number 7, they gave us a certain number of liters. So because they gave us liters, we got to use 22.4 liters is 1 mole. And then when we don't have 22.4, they gave us 672 liters of nitrogen gas. And we want to find X moles of nitrogen gas. So we're going to cross multiply 22.4 times X equals 1 times 672. So divide by 22.4 on both sides. And X ends up equaling 30, actually. Right on the nose. 30 moles of nitrogen gas is the answer. All right, number 8. Number 8, oh, now they gave us, we have a balanced equation of 3 Fe plus 2 O2s forms Fe3O4. Right, and then let me change colors. And then we want to find out X grams of this guy, given that we have 65.2 grams of this guy. So this is grams to grams, because we're going grams of this to grams of that. So we need to know the molar mass of each of these other substances. So iron is 1 times 56, all of that, times the big 3 out in front. So that turns out to be 168 grams. And then we do this one where there's 2 oxygens times 16, all of that, times the big 2 out in front. So that's 32 times 2, so that's 64 grams. So we gotta set up our ratio using these two. So we get 168 grams of Fe combines with 64 grams of O2. And then I go to, well, I don't have 64 grams. I've got 65.2 grams of O2. We're going to find X grams of Fe. So from there, cross multiply 64 times X equals 168 times 65.2. Divide by 64, divide by 64, and X ends up equaling 171. And that's grams of Fe that we just found out. So that's my final answer for that one, for number 8. All right, looking at my time, I'm going to stop there. We're going to go to part number 2. So we'll see you in part number 2 in a minute.